So we're looking at the 4.1c practice quiz today. And this quiz says, this dataset contains the global estimate of cumulative HIV cases worldwide. A scatter plot with the least squares regression line superimposed and a residual plot from Crunchit are displayed. So we can see we've got our table of data over here, and we have a best fit line right here on our data, and we have a residual plot as well. And it might have been helpful if they had shown that this right here, this imaginary line that I'm tracing here, is the x-axis. So the first question says, how well does the linear model fit these data? And we need to justify our answer. So the thing that you need to think about when you're looking at this question is not to just look at the scatter plot and the best fit line alone. Because if you only look at this first graph up here, you might think to yourself that that data fits that line really well because the points are actually very close to that line. There's appear to be very small residual values. And so you might think, okay, the points look like they form a line, so a linear model is a good fit. However, if you look at the residual plot, you can see that there is a clear curved pattern of the residuals, which is a quick thing that should stick out to you and stand out to you, that tells you that a linear model is not a good model for the data points. So I wrote down the linear model is not appropriate since the residual plot shows an obviously curved pattern. There also appears to be a slight curve in the fitted line plot of the data points. So up here, there is a slight curve, which you might see, you might not see, but that curve becomes very obviously evident when you look at the residual plot. So that tells you that a linear model is not a good fit. The second question says, some experts warned that the number of cases of HIV infection was growing exponentially. That's the key right there, exponentially. Use your calculator to perform an appropriate transformation of the data to achieve linearity if the underlying relationship between the variables is exponential. Perform least squares regression on the transformed data. Record your regression equation below and define any variables that you use. So exponential regression is where you take the log of the y values, and that is going to be your equation. So you can see I put a little note here that says I put the data in the calculator and used the log of L2, and then I plot, okay, etc. So let me pause right there, and I'm going to show you over here on the calculator. So you go to Stat, Edit, and you can see that I've already put in the data from this table in my calculator. And what I'm saying down here is I put the data in the calculator and I used the log of L2. So what I'm going to do is I'm going to go over to list 3. And up here I'm going to plot the log of list 2. So now I've taken the log of all the y values, which are the HIV infections, the HIV infection rate in millions of people. And I'm going to plot list 1 against list 3 to figure out my linear equation. So I'm going to go back to my main screen. We're going to do stat, calc. We're going to do the choice 8 for linear regression. And our x list is list 1, our y list is list 3 this time. We're going to store this in our calculator so we can look at it later in under y1. So we're going to have variables, y variables, function, y1. And then calculate is going to paste the format over here, and it tells us this line. So you can see on my paper, I have A is 0.3409. The equation is y equals a plus bx, 3.3409 plus b, which is 0.0766, rounded to 4 decimal places, and times x. So in my equation, x, instead of using y and x, I'm just going to use the actual variable titles. So instead of defining them, instead of using x, I'm using the years since 1980, which was our x variable, and our y variable was the HIV infections. But remember, because we did the log of the y values, it's not just HIV infections, it's the log of the HIV infections. So that is the regression equation. And just real quick, now that I've stored the regression equation in my calculator, um, I can go up to y equals, and I can see that that equation is pasted in here. I can go to second y equals, and I'm going to turn plot 2 off because I don't need that thing on right now. And I'm going to go back up here to plot 1, turn this on, and I'm going to look at list 1 and list 3. You can see we have the scatter plot highlighted. And now I'm just going to go zoom 9, which is zoom stat. You can see that is almost a perfect line right now. That looks like it goes through all the points. If I did want to go look at the residual plot for this, turn this on, and now I'm going to turn plot 1 off. Let's see what the residuals look like. I still see kind of a curved pattern, but they told us to use exponential, so that's the thing we're going to stick with. We're going to come back over here to question 3. It says that we need to use the model from question 2 to predict the number of HIV infections for the year 2000. So this table has data as the years since 1980. So the first thing you need to think about is that 2000 is 20 years since 1980, so we're going to use 20 as our x variable. So taking our equation, we plug 20 in for x. Just some basic algebra. You get the right side is 1.8729, and that's equal to the log of the HIV infections. The way you get rid of the word log over here to get the HIV infections by themselves is that essentially you just take this number and you make it the exponent and 10 the base, and then the word log goes over it. And I can show how to actually do that manipulation in class, but I don't have it written on this paper here. And if you took Algebra 2, or if you have taken pre-calculus, you should know how to do this already. But then all you need to do is put in your calculator 10 to this power. So I just showed up over here real quick, 10 to the 1.8729 power. Gives us 74.6. So our final answer is that we estimate that there's going to be about 74.6277 million HIV infections in 2000. And make sure you include the million on there because the units are in millions of infections. And that's the whole quiz.